In some cases, one solution can be made from another solution. It's sometimes appropriate to apply some language to help understand this circumstance. Sometimes we refer to the original solution as the stock and the prepared solution as the dilute solution. It would be standard practice to take stock solution to prepare a more dilute solution. In this case, it looks like we'll be taking 10 milliliters of stock solution, delivering it to another flask, and then filling it to the line of 250 milliliters. Essentially, this prepares a more dilute solution from the stock. In reading the words of the problem, what we should always look for here are pairs of ideas that relate concentration and volume. When looking at the chemical formula for understanding solutions prepared by dilution, we see C1 times V1 equals C2 times V2, which essentially means the concentration and volume of the stock solution that were used is equal to the concentration and volume of the dilute solution that is prepared. When reading carefully, it asks what is the concentration of 250 milliliters. This is a pair, a C and a V. In this case, the C, or concentration, is unknown, but the V is known. Reading further, we see another pair, 10 milliliters of 1.5 molar solution. Therefore, we have a C1 and a V1, C1 being concentration of 1.5 molar, V1 being 10 milliliters. That would be equal to the new concentration, which we will leave as C, and the new volume of 250. Therefore, we arrive with 250 times C. We simply solve for the C in the equation. By multiplying the two terms on the left side, we arrive at the value 15 equals 250C. Wishing to solve for concentration, or C, we would divide each side of the equation by 250 to reveal the concentration of the dilute solution. 15 divided by 250 reveals the new concentration. The new concentration of solution then becomes 0.06 molar solution, since concentration is expressed in molarity in this instance. You can see this concentration amount is far more dilute than the original concentration of 1.5 molar. That is because only 10 milliliters of this stock solution was brought over to a flask and then diluted with water to a volume of 250 milliliters. Let us look at another related example. Again, reading the problem, we're trying to assign a concentration and a volume of stock compared to a concentration and volume of dilute. The question asks what volume, which would be a V, of 2.5 molar solution, which is a C. We therefore have a pair, volume and concentration, needed to prepare 500 milliliters of 0.75 molar. This solution is now less dilute than the original because the concentration is lower. Therefore, this is also a pair, 500 milliliters and 0.75 molar. Setting up the formula, we know the concentration of the stock solution is 2.5 molar. What we do not know is what volume we would need to prepare the new solution concentration, C2 of 0.75, with a total volume of 500 milliliters. Setting up the equation, 2.5V equals 0.75 times 500. Beginning to solve for V, we would multiply 0.75 times 500 and arrive at 375. We can then isolate V and solve for V by dividing each side by 2.5. 375 divided by 2.5 solves for V, and we would end up with a volume of 150 milliliters necessary to prepare this concentration of solution interested in the problem. Let us look at an example where we will be solving for one of the unknown variables of the dilute solution rather than the concentrated or the stock solution. In reading the words here, we are looking for the pairs of concentration and volume again. When reading carefully, it asks what volume of 1.25 molar solution is prepared if 50 milliliters of 5 molar solution was used to prepare it. Thinking logically, 5 molar solution is more concentrated than 1.25. Therefore, C1 can be assigned the value of 5 with the volume of 50. C2, 1.25, with an unknown volume. Since the problem asks what volume, we assign V to that. Beginning to solve, we get 250 equals 1.25 V. To solve for V, we would divide each side of the equation by 1.25. This would isolate V and allow us to solve for the exact volume necessary. This would require a volume of 200 milliliters. The key to solving solution by dilution problems is always to look for the pairs of concentration and volumes that logically fit together. Sometimes the word "of" is a significant tie to allow you to understand that. Looking for the concentration of the dilute and looking for the concentration of the stock is also sometimes useful because a dilute solution should have a lower concentration than a stock. Applying the formula logically requires you to read carefully as well.